Hey guys. Okay, so excuse me. This is the first video for chapter 15. Believe it or not, we are finally at the um, step 8 of the research process. If you remember way back at the beginning of the first part of this course, at the beginning of the textbook, you talked about the steps in the research process, and we have reached step 8, which is evaluating the data. And so this chapter, before any of you hyperventilate, some of you probably have already looked at it, but it's for those of you who are scared of numbers or the statistical part of this process. This chapter is really more of a conceptual focus. So it's really just talking about um, what statistics is intended to do, and how that goal is accomplished, depending on the data set and depending on the statistical procedure that is used. It's not the super detailed formulas and calculations and all the number stuff. That is for a different course. So this chapter also is going to provide you a roadmap to help you guys, um, to direct you, to guide you to the appropriate statistical procedure that you need for your own experiment. If you were to do your own study, experiment, study, whatever. It doesn't have to be an experiment per se, but whatever you're doing, this also kind of helps you. There's two appendices as well. It says in Appendix B is some examples of all the procedures we're going to talk about in this chapter. And then Appendix C is step-by-step instructions for SPSS, which is similar to JASP. For those of you who have never heard of SPSS, it is statistical software that is commonly used. And so you guys are going to be at least, not necessarily comfortable with, but at least introduced to two different statistical software packages by the end of this course, which is very cool. Because if you go on to do any kind of research, or even if you're just going to be in a job or a role someday where you have to understand research that you're presented with, you can understand where some of that comes from, especially from a calculation perspective in um, a software program like SPSS or JASP. So let's get started. There's this little activity. Obviously, we can't do this in class because we are not in class, but the idea of, I'm sure many of you have probably played the two truths and a lie game, or you have seen examples of it where someone gives you two truths and a lie, and you have to figure out which one is the lie. So the example is, I'm 20 years old, third born in my family, I'm 90% happy most of the time. Specifically, this icebreaker is requiring you to use numbers. So each of your truths and your lie have to have numbers in it. And the idea is to see what the lie is. And I probably should have, this PowerPoint was created by someone else, but I probably should have changed that to be two truths and a lie about me. Obviously, there's actually two lies and a truth here, because I'm not 20 years old and I'm not third born in my family. I'm firstborn, but I am 90% happy most of the time. I could say that's true. So, but the idea here is to get you guys thinking about how easily numbers can be manipulated and how easily numbers can be presented in a way that sound truthful, but may actually be misleading or a lie, as we start to talk about statistics. So the chapter objectives, there are 12 for this chapter. So there's 6 on this slide and there's 6 on this slide. Again, you can screenshot these, but they are also in your textbook at the very beginning. Okay, and so for the first section here, we're going to just kind of introduce the role of statistics in this whole research process. Um, and this is going to cover learning objectives 1 and 2, which means we're going to define 2 general categories of statistics, which are descriptive and inferential. We're going to learn exactly what those are. And then what the purpose is for each of those. And then we're going to define a statistic and a parameter, those 2 key terms, and explain or talk about the role that each of those plays in inferential statistics. So we have collected our data, okay, in our research process here. We've collected our data. We now have lots of scores and measurements and observations, pages and pages of information, and we need to make sense of it all, right? How in the world do we do that? Well, that's where statistics comes in. So, statistical methods have 2 principal purposes. Um, they want to help us organize and summarize our data, um, and that's basically just so we can see what happened in our experiment and see what those results are and communicate those results to others. um, Now, statistics also helps the researcher answer the general questions that initiated the research, right? So we're hoping that at the end, we are able to show or demonstrate with our statistics that we were able to answer the question that we had at the very beginning of our research process. That we were able to answer the question that brought all this about. It also can help um, us determine what conclusions are justified based on our results. And these purposes align with the 2 basic types of statistics, which are at the bottom here. We have descriptive and inferential. Descriptive statistics are those methods that help us organize, summarize, and simplify the results obtained from research studies. So they are, um, it, we'll talk a little bit more about that in the next video, but basically, that's the part that really just helps us um, make sense of it all. Like I said, um, inferential statistics takes it a step further. And so they are the methods that are going to use those results that we obtained from a sample to help us make those generalizations that we've talked about to the population. So, we've talked about several times that one of the goals of research is to use the results that we get from the samples in order to say, if this was true here, then it's likely true for the larger population that we pulled the sample from. And inferential statistics is what allows us to do that. So, before we get into what all of those mean and more, in-depth information about descriptive and inferential statistics, your book wants to make sure to point out that you have to plan ahead. What that means is you don't start thinking about statistics all the way in step 8. Step 8 is when you perform the statistics, when you evaluate the data. But way back at the very beginning of your study is when you should be thinking about statistics. So just like at the very beginning of the research process, you had a lot of things, a lot of decisions to make. Statistics should be included in those decisions in order to determine what you're going to how you're going to design your research and all of that. Because, as this points out in these bullet points, you have to decide how you want to describe your results and which kind of descriptive statistics you're going to use, um, and possibly what kind of inferential statistics you will use. Why? Because if you need, for example, if you're going to, want to describe, or if you're going to want to say the average of something, which is the descriptive statistic, you're going to need numerical data. So you can't only collect verbal data if you're going to want to calculate an average of something. You have to have that numerical data. So that would play into how you design your study, right? What kind of measurements you take if you need that numerical data. And same with inferential statistics. We'll talk more about the different types of those in later in this chapter, but there are certain types of numbers and certain types of data that you will need for certain types of statistics. And so if you're wanting to be able to come to a certain conclusion, you have to use a specific type of statistic to do that. And in order to use that specific type of statistic, you have to have a specific type of data. And so that kind of, works backwards a little bit in order to determine exactly what kind of score you need or what kind of data you need, which helps you, again, design your study. This last point, again, kind of goes along with it. What kind of conclusions you want to make. So, like I said, it's a backwards process. If you know you want to make this certain kind of conclusion, which we'll talk about this when we talk about inferential statistics, I'll give you more examples of this and it'll make more sense. But if you know you want to make a certain type of conclusion, that leads you to say, well, then I have to use this type of statistic in order to do that kind of conclusion. And if I want to use that type of statistic, then I have to collect this type of data. And if I have to collect this type of data, then I have to design my study in this way. And so that is a perfect example of how you have to plan ahead. You have to think about statistics long before you reach step 8. Okay, one more thing we want to talk about before we get in depth here. Statistics terminology, there's 2 key things you need to know. When we talk about a statistic, sometimes people will use this incorrectly, just like correlation and causation. We've talked about the word cause and effect, how people use that when it's inaccurate. There's other examples of things we've talked about of terminology that people can use incorrectly in general in the general world or in the media. But a statistic is one of those. Technically, a statistic is a summary value for a sample. It's describing a sample. So it's describing or summarizing an entire set of scores in a sample. So the example here is the average, or it says the average score for a sample. So the example in your book is the average intelligence score for a sample of students that they, collected. And so that, saying that the average IQ score is, 110 for that sample of students, that is providing you information about the average overall general consensus of intelligence of that sample, right? But it also is providing you a little bit of information about the corresponding population. So where did you collect that sample from? If you collected that sample from a small group of students in the school, then the student body at large, or maybe if it was only from second graders, then the population of second graders at large, you would hopefully assume that the IQ of the general population is going to be similar to your sample. Now, if you want the actual specific data for the population, that's a parameter. So if you actually have the average score for the entire population, that's called a parameter, not a statistic. So your book used the example of a researcher being interested in the now I can't remember if it was study habits or I can't remember what it was. But they were interested in a certain variable about the students in a school, and so they selected a sample of 20 students from that school and got their average score. And so that was a statistic, right? Because it was from a small sample of 20 students from the school. And so that average was a statistic. And we would hope to assume that that would apply to the larger population of the school. It was a college. I think it was a college. Now, if you actually calculated the score, the average score for that entire school, for that entire college, that was the population that they were interested in. That would be your parameter. Okay. As you can probably see, or maybe you're already thinking through, having actual parameters, that's why you don't hear that word very much. You hear statistics more, is because finding the actual parameters is harder. Finding the actual statistical information for an entire population is harder. And that's why we use samples, right? So most research questions start with some kind of concern, or whatever the question is, whatever you're interested in, usually is referring to an entire population, right? You want to know about a population of some sort. So the research question usually is referring to a parameter. We're questioning what parameter that is, or what that parameter looks like for that population. But again, usually we cannot calculate that. So most data that we collect is from samples, right? Because that's easier to obtain. And so that's going to be sample statistics. We're collecting statistics. So this is a great segue or a great example of how we need inferential statistics, because inferential statistics takes those sample statistics and allows us to estimate the population parameters. And that comes back to that whole generalization part of that. And so, again, we'll get more into that when we talk about inferential statistics, but wanted to introduce those two terms to you. So group discussion activity, obviously we cannot do this because we are not in class, but you can read through this. This is getting you guys to think about that research process we just talked about, that planning ahead that we just talked about. If you have a certain question or a certain hypothesis, what kind of descriptive or inferential information are you going to need? And what kind of conclusions are you going to want to make? And again, you can work backwards depending on the kind of conclusions you want to make. That may lead to what kind of statistics you need. Okay, and then learning check really quickly. Which general category of statistical methods is intended to answer questions about a population by using sample data? So we want to answer questions about a population using sample data. And as we just talked about, that is called inferential statistics. We are inferring something about the population based on our sample data. That's why it's called inferential. Second question is, a researcher is interested in the sleeping habits of students at the local state college. The average number of hours spent sleeping each night for the entire set of students enrolled at the college is an example of a. So we are interested in the sleeping habits of students at the college. So the whole college is our population. Then if you look, they didn't sample here. The average number of hours spent sleeping each night for the entire set of students. So they actually got the information for the entire population at the college. So it would be a parameter, not a statistic, because they were able to actually get data from the entire population they were interested in. So remember, population equals parameter, sample equals statistic, okay? If this had said that a researcher was interested in the sleeping habits of students, of all college students in the United States, okay, so that became their population. And then they took the average number of hours sleeping from one college, then it would be a statistic, because it was not the entire population that they were interested in. They sampled from the population, and so then it would become a statistic. So I hope that helps clarify the difference between those for you guys a little bit. And then the last question is, a researcher uses an anonymous survey to investigate the study habits of American college students. Based on a set of 56 surveys that were completed and returned, the researcher finds that these students spend an average of 4.1 hours each week working on course material outside of class. For this study, the average of 4.1 hours is an example of, so hopefully you guys figured this out already based on what I just said a second ago. It's a statistic because the 56 surveys that were completed and returned was a sample, right? That was a sample of the American college students. That's not all American college students. If they had found a way to survey every college student in America, which would be very difficult, then that would have been a population parameter. But since it wasn't and it's a sample, it is a statistic. So hopefully that guys, let me try that again. Hopefully that helps you guys. And that's it for 15.1.